Okay, welcome back. This is part 2 of lesson 4. We're still doing some descriptive statistics. I'll show you guys some other ways to do them. So we haven't even really defined what statistics is. Statistics are numbers that characterize data sets, such as measures of center and spread. They're used to compare large data sets. So numbers that characterize a data set such as measures of center and spread. And again, they're used to compare a large data set. Used to compare a large data set. Okay? So there we go. That's our definition of statistics. So now let's do some more descriptive statistics. Let's calculate the mean, median, and interquartile range, IQR, and standard deviation for some data. So first data set, how many sisters does each student in the class have? So let's have some data that I've created. So let's say student 1 has 2 sisters, 1 sister, 4 sisters, 1, 0, and 3. So we can see we have 1, 2, 3, 4, 5, 6 different students and the number of sisters that they have. And then next, how many brothers does each student have in the class? Well, one student has 1 brother, another has 2, another student has 3, the next 2 students have 0 brothers, and the last student has 4. So now we want to calculate the mean, median, IQR, standard deviation, okay? Last week we did all of these by hand, okay? Calculating the mean and median is not super bad. IQR takes a bit more time, and standard deviation is very time consuming. So now we are going to do these processes all on the calculator. Okay, so all on the calculator using one variable stat. So let me show you how this works, how we do the one variable stat function on the calculator. So I'm going to turn on my calculator, and hopefully you guys can see this fine. I'm going to go right here to the stat button. Okay, you can see there's the stat button. I'm going to hit that stat button, and then it brings up, I can edit, I can calculate, I can do tests. Well, I want to do some calculations using the numbers that I have, but before I can do those calculations, I have to enter them into a table. So I'm going to go to the editor, and I'm going to hit enter. And now it gives me a table, L1, L2, L3, L4. You can see I've got some numbers in L3 and L4. Those are going to come up later. I've got a variety of these. So I'm going to go all the way back to L1 and L2. So in L1, I'm going to start putting in my numbers for how many sisters. So I'm going to go down here. I'm going to put in 2, drop down 1, 4, 1, 0, and 3. And then I'm going to go over to L2. I'm going to do the same thing for the number of brothers that each student have. 1 brother, drop down 2, hit the down arrow. 3, hit the down arrow. 0, 0, and 4. So now I have all the data points that I need. So now what I can do is I can go back and I can hit stat. And now I can go to calculate. And notice I have all these different options. What we want is one variable stats. And that's going to give me things like the mean, the median, the standard deviation, the first quartile, the third quartile, and then from those numbers you can actually calculate the interquartile range. So I'm going to hit one variable stats, And right now you can see that right now it says L3. Well, I don't want L3. I entered everything into L1. So I'm going to clear this. And then on the calculator, you can see down here in the blue, there's L1, L2, L3, L4, 5, 6. Okay, so you can see we've got 6 different that we can choose from. We want L1. So I'm going to hit second and L1. And I don't need anything in the frequency list. We're not dealing with that. I can just go down to calculate. So now that I've gone down to calculate, so you see I can scroll back and forth. So I'm on calculate, I'm going to hit enter. And boom, it gives me a bunch of values. But you guys need to know what each of these things mean. So first, the X with the line over it, that is your mean. So the mean here is 1.833, and I'm just going to go out to the thousandth place. The median, if I start scrolling down, there we go. There's my median, right? MED, and it's 1.5. And then the interquartile range is always Q3, which is 3, minus Q1, which is 1. So my interquartile range is 2. Standard deviation, that's this number here, the sigma x. Sigma is our symbol for standard deviation. You can see I've got 1.343, and it just keeps going. So I'm going to go to the hundredths place. 1.34. Awesome. And those are my stats. Now I'm going to do the same thing for the number of brothers. So once again, I'm just going to clear this. I'm going to go back to stats. I'm going to go to calculate again. One variable. Now I want to clear this. And here I want to put in, I'm going to hit second. Okay, hold on. So let me do that over again. I'm going to hit second. And then this L2 button down here. And now I can go through and switch down to calculate, hit calculate, boom, it's going to give me my numbers. So my mean is going to be 1.667. My median, if I go down, median is 1.5. So these two have the same median. Q1 is 0, Q3 is 3, so 3 minus 0. My interquartile range is 3, and my standard deviation is 1.49. So this tells me the differences in their means. I can see that. They both have the same median. The brothers data set has a larger interquartile range and also a larger standard deviation. Okay? So let's try one more. We're going to do the same thing. It says the table lists the age of each member of Congress in 2 randomly selected states. Complete the table and compare the data. Illinois, you'll notice, has far more Congress members than Arizona because it's a bigger state with a higher, well, not a bigger state, but it has a higher population. So it has more Congress people. Okay? And then here's Arizona. So again, I'm going to do descriptive statistics like I did before. And if I clear this and I go to stats, notice in the edit, I've already put these numbers in. So I already did L3 and L4 for my stats. You guys are going to want to choose those same things. I'm going to go to calculate. I'm going to go to one variable and I'm going to go second L3 because that's where I have the Illinois information. I'm going to go down to calculate. And so when I do that, I can see the information here that I've got. So the mean of the average age in Illinois for the Congress people is 43.81. We'll go to the hundredths place. The median is 39.5. And then the IQR again is Q3 minus Q1. So it's going to be the age of, that's going to be 58. Minus 28, so the interquartile range is 30, and the standard deviation is about 16.42. So very large standard deviation. So their ages are all over the place. Now I can do the exact same thing for Arizona, stat, calculate one variable, clear that out, and choose L4. Go down to calculate. So the mean age of Arizona Congress people is 40.67. The median, if I scroll down, the median is 42, so they have a higher median in Arizona. And my interquartile range, the upper limit is the age of 51 minus the lower age is 26. And so, oops, I'm sorry, not 26. I was looking at the wrong thing. 29.5. So my interquartile range is 21.5. And then the standard deviation, sigma x, is 10.84. So there is a much smaller standard deviation. So now, what does that tell us? Well, the mean average age is lower in Arizona than Illinois. So the members in that Congress are younger than the ones in Illinois. But the median in Illinois is younger, so that means there are more young Congress people in that group. So the average age isn't younger, but there are more of them. The IQR is lower in Arizona, so the ages of Congress are closer together in Arizona than they are in Illinois. Okay? Now let's compare some data distributions. We've got symmetric, skewed to the left, skewed to the right. Well, what that means is if we're looking at data distributions, if our data distribution were to look like this. Okay, so if it just kind of forms a nice curve, sort of a nice bell shape there, that's symmetric. Whereas skewed to the left would look more like this. So if we have a distribution that looks like this, where the curve is, all the way over here, we have these left outliers. Okay, so this is skewed to the left. Skewed to the right looks the exact opposite of skewed to the left, where the outliers are all the way over to the right. And so you can see the differences in those skews.